Welcome to the ET420 Microbit Lab LED lights. This is the way that I wired the LED up. I went from the ground, flat side towards ground, chose a bus, put my 220 ohm resistor and went back to P14. And that's that simple. I copied and pasted the program from the website, and while true will mean this will continue to repeat, so we're going to turn the LED 14 on, wait half a second, turn it off, wait a half second, and then repeat. So let's try it. So let's see if I could connect. And let's flash, and my LED is flashing as it's supposed to. Here's a program where we're going to vary the intensity of our LED, and our analog is basically pulse width modulation, but we're going to have a choice to go from 0 to 1023. 1023 should be our largest and 0 should be our smallest. So let's go ahead and run it. Okay, and it's working perfectly, and it'll run continuously because of this statement. This is the way that I wired the second LED. I plugged in our 220 resistor into P13 and connected the two within this straight bus here, and I put the ground, meaning the flat end, on the blue ground. This is the program to run our two LEDs. We have pin 13 on, pin 14 on, wait half second, turn pin 13 off, pin 14 off, and wait half a second. So we're going to get both LEDs on and both LEDs off. And it is working. Okay, let's work with lists. So what we've done is we've set up an array with green, yellow, and red. We've zeroed our index, and we set the color to that, and we're going to print color, whichever color is on our list. We're going to wait a second, then we'll increment our index, and we're going to continue until our index is 0, and then we're going to print. Let's go ahead and flash it. And wait a minute, let's open up our serial, and let's try her again. And we're clicking through our list, and we're going through our list. Perfect. Okay, let's add a third resistor and third LED, and I plugged our resistor in P15, so we now have 15, 14, and 13. Again, I plugged the LED in across the bus here, and I plugged it into the blue with the flat. Here's a program I got from the website, and here we're making an array called pin list, and we're going to call pin 13, 14, and 15. And we're going to do a continuous for pin in pin list, and we're going to write 1, meaning turn it on. We're going to wait half second, and we're going to turn it off. So, and then we'll go through all three of these. So let's try it. And it continuously flashes all three in sequence. Good job. We're going to use the zip function, which allows us to use information from multiple lists. Here we have a color list, and we have a time list, and our zip function is going to allow us to do both. So we're going to go ahead and run our serial and see what happens. So we're going to flash it, and we're going to open our serial port, and green 1 second, yellow 200 milliseconds, and red 500 milliseconds, and done. Good. Okay, this is my circuit for measuring the voltage of our LED output, and I've hooked P2 into P13, and P0 goes to our common or ground. There's no need to use those fancy alligator clips when we have our jumpers. Okay, let's download our hex program for our voltmeter, and I'm going to right click and save link as. Save it somewhere you could find it. I'm going to put mine on the desktop. Good. Okay, let's load and save our program. We're going to browse. We're going to find it. I'm going to open it, and it pops up. Good. So I'm going to flash it, and I'm going to open our serial terminal, and 2.9 volts on, 0 volts off. Perfect.